Okay, so this question here, we've got to see where this curve meets this curve. So if we put the two equations equal to each other, we've got x to the power of 2/3 minus 1 equals x to the power of 1/3 plus 1. If we get everything on the left hand side, that'd be x to the power of 2/3 minus x to the power of 1/3 minus 2 equals 0. And now the title kind of gives this away, but this looks like a quadratic in disguise. So if we let y equal the middle term here, which is x to the third, then y squared will be x to the third times by x to the third, which is x to the power of 2/3 when you add the 2/3 together. So that's good news, because now this is y squared minus y minus 2 equals 0. And that's, you could use your calculator to solve this, but I think it will factorize. So it's got to give us minus 2 there. So I guess plus 1 minus 2 would work. So that means that y is minus 1 or y is 2. Don't forget we need to put it back in terms of x. So that means x to the power of 1/3 equals minus 1, or x to the power of 1/3 equals 2. To get x on its own, we need to raise both sides to the power of 3. So if we cube both sides here, we're going to get x equals minus 1 and x equals 8. All we need to do now is find the y values. We can do that by substituting the two x values into either equation. I would put them back into this one because it's slightly simpler. So y is going to equal minus 1 to the third plus 1, which means the cube root, that's the cube root of minus 1, which is still going to be minus 1, so y would equal 0. So that's going to give us the point minus 1, 0. And the other point where the graphs meet will be 8 to the power of 1/3, put 8 in there, plus 1. So the cube root of 8 is 2, plus 1 equals 3. So we get 3, which gives us our other point of intersection, which is 8, 3. So the two answers are this and this.